This is a video on how to verify that an equation is a solution to a differential equation. The question is to verify that y equals c1 e to the 2x plus c2 e to the negative x is a solution to the differential equation y double prime minus y prime minus 2y equals 0. And what we do first is we have our y. Let's find our derivatives. We need to get y prime and y double prime so we can plug in. So to take y prime, we use a chain rule. The derivative of 2x is 2, and the derivative of e to something is e to something. So I get 2c1 e to the 2x. And I use a chain rule on the second term also. The derivative of negative x is negative 1. That's why I have a minus sign here. And the derivative, again, of e to something is e to something. So there's y prime. Now let's find y double prime by taking the derivative of y prime. And I use a chain rule again. The derivative of 2x is 2. So 2 times 2 is 4. So I get 4c1 e to the 2x. And then the derivative of negative x is negative 1. So the negative 1 and this negative cancel, and I get plus c2 e to the negative x. Now that I have my two derivatives, I can plug them and my y equation into the differential equation. So I plug in y double prime, which is 4c1 e to the 2x plus c2 e to the negative x, and then I'm going to have a minus y prime, and y prime is 2c1 e to the 2x minus c2 e to the negative x, and then I have minus 2 times y. So I have minus 2, and y is c1 e to the 2x plus c2 e to the negative x, and I put that in right here. So now I just simplify, and again, my goal is to get 0. So I'm going to multiply the negative through, and I'm going to multiply the negative 2 through. So the first terms are still 4c1 e to the 2x plus c2 e to the negative x. Multiplying the negative through, I get a minus 2c1 e to the 2x. And then I have a minus, or a plus, c2 e to the negative x. Then I multiply the negative 2 through, and I get minus 2c1 e to the 2x, and then minus 2 c2 e to the negative x. So now let's just combine like terms and see what we get. Well, for the c1 e to the 2x terms, I have 4c1 e to the 2x minus 2c1 e to the 2x minus 2 more c1 e to the 2x's. So 4 minus 2 is 0. So the e to the 2x terms go away. And for the e to the negative x terms, I have a c2 plus a c2, that's 2c2, minus 2c2, and that's 0 also. So everything cancels, and I end up with 0. So I have verified that y equals c1 e to the 2x plus c2 e to the negative x is a solution to this differential equation. And I'm done with the problem.